Good morning. In this video, we are going to talk about more details on Biot-Savart Law. In the last video, we were talking the magnetic field due to a very small line element dl at a distance r away from this current carrying element, and dl is again a vector quantity. So the small magnetic field dB is equal to mu 0 by 4 pi times the current into dl sine theta by r square. So this is a case where with the length is infinitesimally small. But if we are having an element, a current carrying conductor of very long distance, say from minus infinity, for example from minus infinity to plus infinity. So in this case, consider a point P, for example here a point P which is at a distance A from the line element, that is a perpendicular distance A from the line element. And now we are going to calculate the magnetic field due to the current I, which is flowing through this current carrying conductor. So for that, first we consider a small segment of length dl at a distance, say L from this point. The point P is at a distance r, like we considered before, at a distance r, and this make an angle theta. So what we will do now, we find out the magnetic field at P due to each line segment from here and another segment here and the segment here and the segment here and here. Then we add them together, so we will get the total magnetic field due to the full wire. So instead of that, we can integrate this equation. We can do like B is equal to integral mu 0 by 4 pi I dl sine theta by r square. I dl sine theta by r square. So if I take, for example, the constants outside, then mu 0 by 4 pi, I is a constant, integral dl sine theta by r square. So we integrate from minus infinity to infinity, the whole length of this wire. Here the problem is, if we are going to integrate, here see dl is a variable that we are varying from one segment to another segment to another segment, dl is a variable. So see, dl is a variable from at a far point theta is very small, then theta is also increasing as we are moving up and up, so theta is a variable. As dl is moving this direction, r is also changing, so the dl is a variable, theta is a variable, r is a variable. So that will make our integration very complicated. So for that, we do some kind of substitution. What we do is, we know that r square is equal to a square plus l square. Therefore r is equal to a square plus l square the whole raised to 1 by 2. Also sine theta is equal to opposite side by hypotenuse, that is a divided by hypotenuse is a square plus l square the whole raised to 1 by 2. Now I substitute these quantities here. So if I substitute these quantities here, what I'm going to get is B is equal to mu 0 I by 4 pi integral minus infinity to infinity dl by r square. R square is equal to a square plus l square, and sine theta. What is sine theta? Sine theta is equal to a divided by a square plus l square the whole raised to 1 by 2, and this will reduce to mu 0 I by 4 pi into integral minus infinity to infinity a dl by this is 1 by 2, so the total will be 3 by 2 is by a square plus l square the whole raised to 3 by 2. Now, so our equation is like this: b is equal to mu 0 I by 4 pi into integral a dl divided by a square plus l square the whole raised to 3 by 2. The integration is from minus infinity to infinity. So now I do some substitution. For that, what I'm going to do is I'm going to substitute L is equal to a tan phi. L is equal to a tan phi. Therefore, dl is equal to a secant square phi d phi. So substitute here. So what we get, the limit also will change. And what we get is mu 0 I by 4 pi into what we get is the limit will from minus pi by 2 to plus pi by 2. A, what is dl? dl is a secant square phi d phi whole divided by a square is a square plus l square is a square tan square phi the whole raised to 3 by 2. So I get an a square above the line, and there is an a cube below, that is by 4 pi into integral minus pi by 2 to plus pi by 2. See, here we have an a square. If I take a square raised to 3 by 2, I get a cube. So this will cut, and what I am getting is by a into, on solving this one, what I am going to get is cos phi d phi. Cos phi d phi. So the integration answer is mu 0 I by 4 pi a into sine phi from the limit minus pi by 2 to plus pi by 2. So the answer is 2. So what I am getting is mu 0 I by 2 pi a. So this is the value of magnetic field due to a very long, infinitely long current carrying conductor. Thank you.